Hi, we're Team Christine, one of the 4 student teams in the Fundamentals of Robotics course at Olin College. In this video, you will see our robot boat performing 4 different missions autonomously. We will also explain the code that controls the behavior of the boat and how it was implemented. The task for Mission 1 is simple. After leaving the dock, the boat uses GPS data provided by a camera above the pool to follow a series of pre-planned waypoints. The waypoints are set by a mission definition file, and they guide the boat through a figure 8 around 2 buoys. In order to capture these waypoints, the boat first computes a desired heading between its current position and the target waypoint, then determines a rudder setting that will steer the boat directly toward the waypoint. A waypoint is considered captured when the boat passes within 6 inches of it. In order to complete the mission as quickly as possible, we had to account for the inertia of the boat, which makes tight turns sloppy at higher speeds. We did this by adjusting the boat's desired speed in 2 places. First, in the hindbrain, the boat changes its speed based on the angle of the turn required. The tighter the turn, the slower the boat sets its speed. The boat is only able to steer actively above a particular speed, though, so we cap the thresholding to keep the boat from drifting. Second, in the forebrain, the boat slows down as it approaches each waypoint by computing the straight line distance between its current position and the waypoint. Once it is within 2 or 3 feet of the waypoint, it decreases its speed proportional to its distance from the waypoint. These 2 behaviors together allow the boat to travel fastest when it is far away from a waypoint heading toward it in a straight line, and slowest when it is very near the waypoint and needs to make a tight turn in order to capture it. To complete the second mission, the boat starts out by following a series of waypoints toward the wall. When it reaches the wall, it changes behaviors and follows the wall around the back of the pool. However, when the boat passes under the boards on the right of the frame, it passes out of sight of the camera and GPS information is lost. Underneath this cloud, the boat must navigate using only onboard information. It is equipped with an array of 6 infrared sensors, 2 straight forward, 2 at 22.5 and negative 22.5 degrees, and 2 at 45 and negative 45 degrees. To follow the wall on the port side of the boat, we use the distance readings from 2 sensors to allow the boat to follow the wall while keeping approximately 1.5 boat widths away from it. To allow the boat to react to getting too close or too far away from the wall, we calculate the distance readings that are needed from the negative 22.5 and negative 45 degree sensors that allow the boat to wall follow at the appropriate distance. We then apply PID control to the negative 22.5 and negative 45 degree sensor readings to control the rudder as necessary to keep the boat wall following at the calculated distances. This allows the boat to turn toward the wall when it gets too far away and turn away from the wall when it gets too close. Points are lost for contacting the wall or any obstacles, so the boat also uses all of its infrared sensors to detect any obstacles that are nearby. It then combines all its sensing data together to create a 1D map or behavior array of the location of those obstacles in terms of the local heading of the boat. This information is then later used by the midbrain to avoid anything that gets too close. The boat has the capability to consider inputs from multiple behaviors. Each behavior suggests a rudder angle and indicates how necessary it believes that rudder angle to be. The boat weighs all of the suggestions and chooses the most valuable behavior. For example, as the boat approaches the post at the back of the pool, it becomes much more valuable to avoid the post rather than follow the wall. Once it is past the post, it returns to wall following. The boat completes the second mission by reaching the orange buoy and circling it once. Mission 3 is similar to Mission 1, but in addition to completing the figure 8, the boat needs to return to the dock cleanly. The boat begins the mission by following waypoints to navigate around the buoys. Once it completes the figure 8, the boat plans a path and places waypoints that will guide itself into the correct position and heading to aim straight for the dock. When the boat is within about a foot of the inside of the dock, it switches to its vision system and the 2 45-degree IR sensors to make a fine adjustment and guide itself smoothly into the dock. There is a red circle in the center of the dock, so the vision system locates the red circle in the camera image, if it is visible, and determines its position. The boat applies PID control twice, once to keep the red circle in the center of the image as the boat heads into the dock, and again to zero the difference between the 22.5 and negative 22.5 degree IR sensor readings. Both the camera and the IR sensors are needed for this task. Attempting to dock with either system alone results in failure. Numerous trials allowed us to tune the relative weighting of the IR sensors and vision system in order to dock as smoothly and accurately as possible.